How are you doing? It's Sunday night, and it's an interesting night to approach the biggest problem that we're having right now. And for 5 minutes, I'd like to talk about some things I've learned about the virus and problems the virus is causing on our bodies as humans, and ways that we can try to combat and beat the virus, especially on the molecular level, which is what you're looking at right now. So let's see how we can do here in 5 minutes. What you're seeing here is a rendering of the spike on the edge of the uh, coronavirus, the actual spiky ball. There's a spike or several spikes. That's this gray thing right here. I believe it is attached to the rest of the virus, which is like a balloon down here. These two things down here. I believe that that's what locks it to like the rest of the virus, which would all be all the way like all huge under here, like, way under here. There'd be a big, huge ball. So this receptor thing, this gray thing, this weird shape, it is kind of sticky or like has pokey sides to it and arms almost. It's got two arms, and then a crevice here. And there's all these different wavy lines and flapjack type things and circle things and weird bonding things that are showing here, because it's showing a lot of potential energy or ways that this receptor would bond to things in your body because its polarity or its charge or its pH. There are a number of factors that can affect it. And these are things, spooky things coming out that we don't really have to understand right now. But know that we're trying to design something that bonds to these in such a way, something we can create a protein at the molecular level, which is what this yellow thing is, to try to bond it so that it will fit right in snugly and block this spike from getting into like our lung cells or hitting our ACE2 receptors, as it's called, parts of our body that we don't want this virus to impede and get into our cells and perform its replication instructions on our cells so that our cells just explode with more virus and infect more. We're trying to stop it. So if you can circulate the body or the lungs by breathing something in that is a protein that won't hurt the rest of your body, but just is built like a lock or a key for this that will fit snugly in, then you can like grab it and bring it down there, I think. I don't know. I'll figure out how to use that eventually. Um, it'll fit snugly right in here. So we are about 3 minutes in. So what's cool about this and why I really applaud what they're doing at Fold It. Fold It is the place to go to get this. Fold It, FOLDIT. It's simple. What's really cool about this is this thing right here. There's a blueprint of the amino acids that this thing is. And you can actually trace, you can see that it probably starts coding for its protein right about down here, and I'll tell you why. Let's assume this is the beginning right here, which is this A thing. It's right here. Then it becomes like a sheet, which is this thing. This is a sheet design. Becomes a sheet. Then after it becomes a sheet, you follow this thing up like this, right? Then it becomes a little bit of a coil here, or a helix as they call it. This thing is a helix. We just went from here and turned into a helix right at this spot, I believe. Or we went from here actually. We went from sheet to helix right there. Then you turn into this helix, which is this great thing right here. It's this. And if you get in there, right, I love how you can just move around and render through all this stuff. I can actually turn these bonds off, these things that are poking out, but they mean something, and I just don't understand what everything means yet. But this coil then turns into a bunch of lines, which is this line, 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 and then it turns into a coil again. Where? No, it looks like it turns into a sheet here. It's interesting. So this 3D structure on the molecular level is what we're trying to bond to. I think the best way overall to look at it and to design against it, and how I'm going to approach it Wow, that thing kind of sticks out. Look at that. Is that really true? Does that thing really stick out that far? See what I'm talking about? This thing up here, this is the part of it that we're worried about, this top part of the virus. We're at 5 minutes, but